Day 461 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 3363. Find the maximum number of fruits collected. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There's a game dungeon comprised of n by n rooms rearranged in a grid. You're given a 2D array fruits of size n by n where fruits of I and j represent the number of fruits in the room I, j. 3 children will play the game dungeon with initial positions at the corner rooms 0, 0, 0, and n-1 and n-1 and 0. The children will make exactly n-1 moves according to the following rules to each room n-1, n-1. The child starting from room 0, 0 must move from their current room ij to the one of the rooms I plus 1 and j, or j and j plus 1, I plus 1 and j, or I and j plus 1 if the target room exists. The child starting from room 0 and n-1 must move from their current room ij to one of the rooms I plus 1, j minus 1, I plus 1 and j, and I plus 1 and j plus 1 if the target room exists. The child starting from room n-1 and 0 must move from their current room I and j to one of the rooms I minus j and j plus 1, I and j plus 1, and I plus 1 and j plus 1 if the room exists. When a child enters a room, they will collect all of the fruits there. If there are 2 or more children enter the same room, only one child will collect the fruits and the room will be emptied after they leave. Return the maximum number of fruits a child can collect from the dungeon. All right, y'all, so that may seem confusing at first, so let's go ahead and take a look at these examples just to make sure that we understand what the question is asking. So in example 1, we have our input fruits, which is a 2D array, first array being 1, 2, 3, 4, then 5, 6, 8, 7, 9, 10, 11, 12, 13, 14, 15, and 16. Now, as you can see, each one of these arrays inside of the 2D array, so this array, this array, this array, they each represent a different row. So, right, as you can see, this is row 1, right? 1, 2, 3, 4. This is row 2, 5, 6, 8, 7, 5, 6, 8, 7. This is row 3, 9, 10, 11, 12, 9, 10, 11, 12, and row 4, 13, 14, 15, and 16. Boom. So let's look at this explanation. The explanation says the first child, which is in green, so each color represents a child and the path that the child is taking, right? So the first child, which is green, moves from the path 0, 0 to 1, 1 to 2, 2 to 3, 3. So it starts right here, 0, 0. Then goes to 1, 1 right here, which is really just going over 1, down 1, or down 1, over 1, right? So boom, now we're at 6. Then we go to 2, 2. So starting from here, we go over 2, down 2, 1, 2, down 2. Now it's at 11. Then from starting right here, it goes 3, 3. So it goes 1, 2, 3, 1, 2, 3. Excuse me, 1, 2, 3. Or excuse me, 1, 2, 3, and right here. And it ends at 16. So, boom. That's how that works. Then child 2, the child in red, moves on the path from 0, 3 to 1, 2 to 2, 3 to 3, 3. So the second child, which is the red child, starts right here. Then it starts with, this is 0, 3 right here. Then it goes to 1, 2. So we're starting from this side though. So 1, 2 would be, we go over, or we go down 1 over 2, right? So we come down 1 over 2. So down 1, 1, 2. Now we're at 8. Then it goes to 2, 3. So it comes down 1, 2 over 3. 1, 2, 3. Boom. So as you can see, this is the path of the second child, the red child. Then it goes to 3, 3. So down 3, 1, 2, 3 over 3. 1, 2, 3 ends at 16. Boom. Then The third child, which is blue, moves on the path 30 to 31 to 32 to 33. So this is the blue child right here, 13. It goes from 30, which is right here, so down 3, 1, 2, 3 over 0, so it's right here. Then it goes down 3 over 1, so it goes 1, 2, 3 over 1 to 14. Then it goes down 3 over 2, so it goes 1, 2, 3 over 2, 1, 2 to 15. Then it goes down 3 over 3, 3, 3 all the way to 16. So 1, 2, 3, 1, 2, 3. Now we're at 16. So overall, they collect, the output is 100. So they collected, we're counting the number of fruits combined, that all of the children combined. So the first child, the green child, right, first child right here, collects fruits 1, 6, 11, and 16, right? So boom, right here, we add all those together. That's how many fruits the first child collected. Second child collects 4 fruits, 8 fruits, then 12 fruits, then 16 fruits, right? But the 16 is already collected, so we don't have to count that because it says right here, if two or more children enter the same room, only one child will collect the fruits and the room will be emptied after they leave. So since the first child already collected this 16, the second child, this red child, there's no 16 to collect. It just collects 4 fruits, 8 fruits, then 12 fruits. Then the third child, the blue child, collects 13 fruits, 14 fruits, and 15 fruits right here. And when we add all of the fruits together, we get 100 fruits. That's how we got 100, because that's how many fruits that all of the children collected all together. Not just one child, all of the children, all the 3 children took all of their fruits, threw them in a basket, and counted up how many they were able to acquire in the end, and that's how we got the 100. So let's go ahead and take a look at example 2 just to really make it make sense. Example 2, they don't give us the visual representation, but it's simpler because there's just not as many squares. So in example 2, we have our input fruits equals the array of integers, 2D array of integers 1, 1, and 1, 1. So this would be row 1, this would be row 2. So there's only 4 fruits total anyway. So first child moves from 0, 0 to 1, 1. Boom. Second child moves from 0, 1 to 1, 1. And the third child moves from 1, 0 to 1, 1. In total, they got 4 fruits, right? So the first child got 2 fruits. The second child got another fruit right here, and then the third child got another fruit right here. These fruits were already taken by the first child, so in total, there are 4 fruits. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution, y'all. Solution is not that difficult. Now, the first thing we're going to do is we're going to get the number of rows and columns in the grid. So we're going to say let n equal fruits.count. Boom. Then we're going to come down here and we're going to initialize our dynamic programming array with the same structure as the fruits. So dp I and j will store the max fruits collected when reaching cell ij. So we're going to declare a variable, call it dp, and we're just going to set that equal to fruits, just like that. Now we need to compute the middle index used for our symmetric logic. So our symmetry logic, So we're going to say let middle equal n divided by 2 plus, not times, plus n mod 2. Boom. Then we need to iterate through the rows starting from the second row. So we are going to say for I n 1 ... less than sign n, we're going to open up the brackets. Now we're going to collect fruits by moving diagonally from I minus 1 and I minus 1 to II. So to do that, we say dp square bracket I what we're going to do is we're going to say plus equals dp square bracket I minus 1, come outside of that, and another square bracket I minus 1, like that. Now we're going to skip processing on the last row since we're already accessing I plus 1. So we're going to say if, come underneath this, and we're going to say if I is less than n minus 1, we're going to open up the brackets, and we need to determine how many symmetric elements to consider. So we're going to say let S equal middle minus ABS, open up the parentheses, middle minus I. Boom. Now we need to iterate through J to handle the symmetric positions across the diagonal. So for that, we're going to come underneath this, and we're going to say for JN 0 dot 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 S, we're going to open up the brackets, and we're going to avoid double counting the center or diagonal by saying if I exclamation point equals does not equal n minus 1 minus j, then we're going to open up the brackets. Now for the now we're going to calculate the left and right neighbors from the previous row by saying we're going to say var left index. We're going to set that equal to the max, open up the parentheses, n minus j minus 2, comma, n minus s, minus s. Then we're going to come underneath that, and we need to calculate for the right neighbors. We're going to declare a variable called right index, and we're going to set that equal to max, open up the parentheses, n minus j minus 1, comma, n minus s. Now the max fruits collected so far from the top neighbors, we need to get that. So we're going to come underneath this. We're going to declare a variable called s, or excuse me, not s. We're going to call this one a. And we're going to set that equal to max, open up the parentheses, dp square bracket I minus 1, come outside that square bracket, and we're going to open up some more square brackets, but still inside the parentheses, and we are going to say square bracket left index, come outside of that square bracket, we're going to say comma dp square bracket I minus 1, come outside of that square bracket. This time we're going to say right index. Boom. Now we need to also compare it with the straight top neighbor. So come underneath this variable, and we're going to say dp square bracket I, come up. Sorry, y'all, it should be dp square bracket I square bracket n minus 1 minus j, come outside of that. I'm going to say plus equals max, open up the parentheses, a, comma, dp square bracket I minus 1, come outside of that square bracket, and then we're going to say open up more square brackets, and we're going to say min, open up the parentheses, n minus j, comma, n minus 1, just like that. Now we need to repeat the logic, but for the mirrored coordinates. So we're going to come right here underneath this, and we are going to say left index equals max, open up the parentheses, n minus j minus 2, comma, n minus s. Come underneath that, we're going to say right index equals max, open up the parentheses, n minus j minus 1, comma, n minus s. Sorry, y'all, and this should be n minus s, not n minus 2. I don't know how that 2 got there. And then this, could delete that. That shouldn't be there either. Then we need to get the max fruits collected from the left neighbor. So we're going to come right here. We're going to say A equals, let me just give y'all some space so you can read it easier. A equals max, open up the parentheses, DP, square bracket, left index, come outside of that, square bracket, I minus 1, comes outside of that square bracket, comma, DP, open up the square bracket, right index, come outside of that right index, and we're going to open up more square bracket and say I minus 1. Sorry, y'all. I minus 1. Boom. Now we need to add the best possible previous value by coming underneath this, and we are going to say dp square bracket n minus 1 minus j, come outside of that square bracket, open up more square brackets, say I, then come outside of that, we're going to say plus equals max, open up the parentheses, a, comma, dp square bracket, min, open up the parentheses, n minus j, comma, n minus 1, come outside of that square bracket, but still inside the parentheses, and we're going to open up some more square brackets and say I minus 1. Boom. Now we need to return the final result, which is the sum of the bottom right corner and its immediate neighbors. So we're going to come all the way down here. We're going to say return dp square bracket n minus 1. Come outside of that, say square bracket n minus 1. Come outside of that, we're going to say plus dp square bracket n minus 1. Come outside of that square bracket, we're going to say square bracket n, this time minus 2. Come outside of that, we're going to say plus dp square bracket n minus 2. Come outside of that, square bracket n minus 1. Now that should be all that she wrote, y'all. So let's give it a run before we submit this. See what, okay, let's see, where's this error? Oh, sorry, y'all. So that should be divided by 2, not a question mark. So now let's run it. See what that does. See if this works now. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 26 milliseconds beats 100% of users. That's what I'm talking about. Those are the numbers that I like to see. So with that being said, make sure y'all get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.